And now students, coming to the third class number system, exercise 1.3, the remaining problems. 1.3 exercise, question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. That means what? Non-terminating and non-recurring. Recurring means repeating. So non-recurring means non-repeating. So that decimal should non-terminate and non-repeat. So that type of decimal, we have to give 3 numbers. Any 3 numbers. First we can see any type of number 0.250, 200, 25000, such a way. You see here, the numbers are not repeating. 250, 200, and then 25000. So like that, it is non-terminating, etc. Non-terminating, and also not repeating. And second example, any number you can use. 3.20, 200, 30, 300, etc. Like that it is. So this is also non-terminating, non-repeating. And then 0.70, 700, 7000. So such a way it goes. So here also non-terminating, non-repeating. So these are the examples. Like this we can give many examples. And question number 8. Find 3 different irrational numbers between the rational numbers 5/7 and 9/11. So these are the given 2 rational numbers, and we know how to find the decimal expansion of 5/7 and 9/11 by dividing the normal long division. You can find the decimal expansion. You see here 5/7 is, if you divide, you get the decimal expansion 0.71428, and after 8 no other digit, it terminates up to 8. So this is terminating. Okay, so it is rational. 5/7 is rational. So it is terminating. And see here 9/11, the next number 0.818181, and we again repeating the same 818181. So you can put dot, etc. Or you can write this as 0.81 bar also. That you know already. And the question is, between these 2 decimal expansion, we have to find 3 different irrational numbers. So as before in some question, here also you have to do the same thing, but between these 2 decimal expansions, we have to select any 3 irrational. Clear, student? And now to write this answer. 0. This is 71. So 7, you can put 2, because here you see after the point the 10th digit is 7. Here the 10th digit is 8. So between these 2, after 71, 72, 73, like that, up to 79, we can write any type of numbers. So 72, 0, 200, 200, etc. So like that, it is an irrational number, which is non-terminating and also non-repeating. So this is an example between these 2 numbers. And they are asking 3. We can write anything. So 0.730, 300, 300, etc. And next one 0.7530, 500, 500. So like that, anyway, you can write as non-terminating and non-repeating. But that should be between these 2. So like this, you can find the answer. Very simple questions. And now coming to question number 9. and they are asking the following numbers which are, that is classified, which are rational and irrational by analyzing the decimal expansion. Okay, and now first coming to the square root of 23. So you have to say square root of 23 is rational or irrational. So how to say? First of all, 23 is a non-square number. It's not a perfect square. So if you take square root of a non-square number, you get irrational. That I already explained clearly. So this is what? Irrational number. Yeah. And now coming to the option 2, square root of 225. So 225 is a square number. Simply we have to know up to 20 square, 1 square, 2 square, 3 square, etc. up to 20 square. If you know thoroughly, then it is easy to find out such numbers is rational or irrational. So what is the 225 means? It's a square number of each square 15 square. So 15 square is 225. So this is nothing but 15 square. And if you take square root of a square number, you get only the number 15. So 15 is the answer. So it is a rational. It is a rational number. So they are asking to find rational or irrational. So this is rational number. And 0.3796. So it is terminating. So after this digit 6, there is no other digit coming. So terminating. From the decimal expansion which terminates, then it is rational. Is it clear? And now coming to 7.478, 478, etc. So the 3 set of digits in the repeating block, 4, 7, 8, and again 4, 7, 8, and etc. It is repeating in such a way. So non-terminate, repeating. Non-terminate, repeating. So such decimal expansions are rational. And this one, 1.10, 100, 100, 100, 1 etc. So it is not terminating, non-recurring. You see, here 10, here comes 20, after that here 000. So like that it is non-repeating. So non-terminating and also non-repeating. So such numbers are called irrational. So this is irrational. So this is the method to find whether the given numbers are rational or irrational. So now the exercise is over. We move to the next exercise 1.5. And now you see here, let A and B be positive real numbers, then root of A into B equal to root A into root B. For example, root 4 into 9, what is that? A4, B, 9, instead of that. So 4 into 9, we can write as root 4 into root 9, which is nothing but root 4 is 2 and root 9 is 3, we get 6. And directly we can say 4 into 9, now 36. So square root of 36 also 6. So this is the way. We can give some examples like this to understand how the formula is coming as root A into equal to root A into root B. In such a way, we can give more examples. Square root of A by B is equal to root A by root B. And we can give example for A 100 and B 25. Root of 100 by 25 equal to root 100 by root 25. And again, root 100 you can write as 10 and root 25 as 5. And 10 by 5 again 2. Whereas, coming to straight way, 100 by 25 you know 4. So square root of 4 is what? 2. The answer 2 only. So this is the formula. So like that we can give any number to all these formula. There are 4 more formulas. So here and we can see how we are getting the right hand side from left hand side. Okay. So you multiply these two. So root A into root A. What you get? A only. Root A into root A. And then root A into this is minus root B. And you get minus root A into root B. Okay, and then if you multiply root B into root A plus, again you can write as root A into root B, and if you multiply root B into minus root B, we get minus B. And you see, this is minus root A into root B, this is plus root A into root B. So cancel. And only A minus B is there. A minus B. So which is in the right side? A minus B. So just simple multiplication. That's all. And now coming to question option 4. If you multiply these two, you get A square minus B. We apply the same multiplication. You see, A into A, we get A square, and A into root B, we get minus, because plus into minus, minus A into root B, A root B, and then B root B into A. So we get plus A root B, like that we can do. A into root B, as in the same order, alphabetic order, and then plus root B into minus root B. What happens? Minus root B into root B, B. And again what you get? This is A square, and this is minus A into root B, and this is plus A into root B. Both of them gets cancelled, and the remaining is minus B only. So this is A square minus B. So what you get in right side? It comes. And now if you multiply these two, the simple multiplication. Root A into root C, we get root of AC. Root A into root C. We can put the same square root, within the same square root, that is this. We can write this as AC. Clear? A and C, AC. That is, it means A and C, the operation is multiple. So in such a way, all are square root only. So if you multiply, you get square root of square root of square root of square root. Square root of A into square root of C, root AC. And then square root of A into square root of D, you get root of AD here. And root B into root C, you get root BC. And root B into root D, you get root of BD. So this is the way we can easily write that. And now coming to the last one, the same way. A plus B whole square, you know already. The algebraic identity A plus B, the whole square equal that A square plus 2AB plus B square. So this is the algebraic identity. And you are applying for root A, root B. What do you get? Root A plus root B whole square. Root A whole square plus 2 into root A into root B, and then plus root B the whole square. We just apply root A instead of A, root B instead of B. You get like this. And now simplifying. What is root A whole square? A. And here plus 2 into root A root B. So we can write as root of AB. The same root we can write root of AB. And this plus root B whole square means B. Square root of whole square. So you get the same number inside the root, that is B. So like that A plus 2 into root AB plus B. Okay children. And now coming to exercise 1.5, the first one is we have to classify all these 5 options, either rational or irrational. Okay? And you know what are the rational and what are the irrational form. And now you say 2 minus root 5. So 2 you know rational. But what about root 5? It is irrational. So when we subtract an irrational number from a rational number, definitely you will get irrational number. So this becomes irrational. And now coming to this option 2, 3 plus root 23 and then minus root 23. So root 23 means irrational. But we have to simplify this. The simplest form we have to bring and then you classify whether it is rational or irrational. So 3 plus root 23 and then after that minus root 23. Then if you cancel plus and minus root of 23, we get only 3 and which is rational. So after simplification of the given problem, we can tell that 3 is rational. So here in the numerator also root 7, denominator also root 7. So 2 into root 7 and this is 7 into root 7. So if you cancel the root 7 in both numerator and denominator, we get 2 by 7 which is rational. And now coming to option 4, 1 by square root of 2. You know this denominator root 2 is an irrational, but numerator 1 rational. But 1 by root 2 means if you divide 1 by an irrational number, definitely we get irrational number. And now coming to 2 pi. You know pi itself an irrational number. So if you multiply 2 with pi, definitely you get irrational number. Is it clear? Is it clear to you? And now coming to the second question. So they are asking simplify. Some expressions are given and we have to simplify it. 3 plus root 3 into 2 plus root 2. So just we multiply, that's all. The usual multiplication, but square root is there. So you have to take care on that. So 3 into 2, 6. 3 into 2, 6. And then 3 into root 2. What you get? 3 root 2. 3 into root 2, you get 3 root 2. And then plus root 3 into 2. Root 3 into 2. What you can write? 2 root 3 you can write like this. Root 3 into 2 you can write as 2 root 3. And then again root 3 into root 2. What comes? Root 3 into root 2. And now you can write this as 6 plus 3 root 2 plus 2 root 3 plus this is you can write as root 6. That's what. Root 3 into root 2 you can write as root of 6. So further we cannot simplify because here 6 but here root 6. We cannot add that. And here you see 3 root 2 and this is 2 root 3. So you see here the root is different number. Suppose we have root 2 here, then we can add 3 root 2 plus 2 root 2 is 5 root 2. And suppose we have here root 3 and here also root 3, then 3 root 3 plus 2 root 3, we get 5 root 3. But here the root number are different, so we cannot add that. So as it is, leave it. Clear? So this is the simplified one. And now here 3 plus root 3 into 3 minus root 3, the second option. So just we multiply 3 into 3, 9, and then 3 into minus root 3, we get minus 3 root 3, and then root 3 into 3, so you get 3 root 3. The root number you just write the next one, okay? Right side. And Root 3 into root 3. Plus into minus. Minus. Root 3 into root 3. 3. If you multiply the same root number. Root 3 into root 3. You get 3. And now. This 9. This 9. And this 3. We can simplify. Here it is. So 9. This is minus 3. 9 minus 3. 6. And this one minus 3 root 3, this is plus 3 root 3, same quantity, opposite sign, you can cancel this. And what you get, 9 minus 3, 6 is the final answer. Clear? And now coming to this one, you know, this is in the form of a plus b whole square, where a is root 5 and b is root 2. So you just apply a plus b whole square identity. So a is root 5. So a square plus 2 into a. What is a? Root 5. And what is b? Root 2. And then plus b square. What is b? Root 2. So root 2 whole square. And now, what is root 5 the whole square? Square root of square is the number itself. So 5. And then plus 2 into root 5 into root 2. What comes? 2 into root 10. That's all. Root 5 into root 2. You get root 10. And then here 2. And now you can add this 5 and this 2. You get 7 plus 2 root 10. Is it clear? And now coming to option 4. So this is the question, option 4. And you take as homework. Okay? Root 5 minus root 2 into root 5 plus root 2. Root 5 minus root 2 into root 5 plus root 2. You take as homework. You can apply it identity a minus b into a plus b. Clear? And now coming to the question number 3. Pi equal to c by d, where c is circumference, d is diameter. And we also know that pi is nothing but the ratio of circumference to diameter of any circle. And they are asking the question. This seems to contradict the fact that pi is irrational. Pi is irrational. That contradicts the fact that pi is irrational. And we have to say, and we have to resolve this contradiction. So we can say c and d are nothing but the measure of the circle, circumference and diameter. For example, if I say to measure the length of these 2 points, can you get exact value as 5 cm or 5.5 or 7 cm? Can you say? No. It may come 5.2, it may lie between 5.2 and 5.3. So we cannot measure it exactly with using scale. Sir, are you sure with that? Are you agree with it? So, if I say to measure this length, we may get a rational, may not. Sometimes we may get irrational also. So if you measure directly a length or any circumference or a diameter of a circle, we cannot say we can get rational only. So C, the circumference, may be irrational, or D may be irrational, or both C and D may be irrational. So we can say pi is irrational only. So there is no contradiction. There is no contradiction. This is the solution we can give for this. There is no contradiction because they are saying that it seems to be pi. It seems to be what? Seems to be contradict the fact that pi is irrational. That means what? Pi may be rational, like that they are saying, but we have given an explanation that pi is irrational because C may be rational or irrational, D may be rational or irrational. Therefore, if you divide C and D, which is either rational or irrational, definitely you will get irrational only. And now coming to the question number 4, represent root 9.3 on a number line. So before exercise, we saw representing root 2, root 3, root 5 and square root spiral. So everything we saw. But here, root of 9.3, a decimal number, square root of a decimal number. How to represent on a number line? Let us see now. So for that, first of all, we have to take AB. The number line is L. AB 9.3 units because inside the root the decimal is 9.3. So for the given decimal, we have to take a measure AB 9.3 units. You can take the unit as centimeter also by using your scale. And from B, 1 unit distance, 1 unit, BC. See here, BC, 1 unit. And next step, you have to draw a midpoint for AC. AC. For that, we have to draw a midpoint and mark it as O. So this O is the midpoint of AC. How to mark the midpoint of that AC? We can use compass method, that is perpendicular bisector. The method is called perpendicular bisector. Perpendicular bisector of AC. If you draw that, you will get the midpoint O of AC. And now, with O as center, keeping the compass pointer at O and OA as radius or OC as radius, you draw a semicircle like this, which pass through or touch A and C. AC. You have to draw a semicircle. And the next step is through B, draw a perpendicular to the line L. Draw a perpendicular. So you have to draw a perpendicular on this. So let it be D, which means the perpendicular through B meet the semicircle at D. This point is, you can mark it as D. Now BD measure is nothing but root 9.3. The measure of BD gives root 9.3 value. And on the number line, we can show you, we can locate it. As B as the, you can keep. So this has 0 because from here DC is 1 unit. Therefore, here we can take as this is 0 and this is 1. So like that we can take it. And this B as the center and BD as radius. If we draw this point, suppose P, this point on the number line represents root 9.3. This is root 9.3 on the number line. Yeah, this is the way to locate the square root of a decimal on the number line. So by using the same Pythagoras property, we can prove it also. Okay? And now we represent this. I have taken AB 9.3, BC 1 unit. You see the figure clearly. And after that, O is the midpoint of AC. And this is the semicircle. Okay? And now I already told you that BD, which is the perpendicular to the line here, is root 9.3. And we see the proof how we are proving that BD is root 9.3. So join OD. We have to join O and D. OD. AC is what? What is AC? This is the diameter of the semicircle. Therefore, up to from AB 9.3 you will get BC 1. So what is AC? 10.3. 9.3 plus 1, 10.3 units. What is AC? 10.3 unit. 9.3 plus 1. And now OC and then OB. OC equal to OD equal to OA. These all radius. You see, OD, OA. O is the center. OC, everything equal, which is nothing but radius of semicircle, and that is nothing but 10.3 by 2, because AC is what? 10.3. So diameter by 2, that is radius. So 9.3 plus 1 by 2, that is 10.3 by 2. So OB, now we are going to find OB. Why? Because in this right triangle OBD, we want BD. We have to prove BD is root 9.3. For that, we need OB and OD. So we are trying to find OB. What is OB? You see the figure. OB is AB minus OA. You see, this is AB, and if we subtract OA from AB, you get OB. Clear? So what is AB? 9.3 already. And what is OA here? All are equal to 10.3 by 2. So 9.3 minus 10.3 by 2, you have to take LCM. So it becomes 18.6 minus 10.3 whole divided by 2, and you get 8.3 by 2. OB 8.3 by 2. And now coming to the right triangle OBD, you see the right triangle. BD square is equal to the hypotenuse square OD square minus this is OB square. So BD square is OD square minus OB square. You can write by Pythagoras. And this is of the form A square minus B square. So we have to write as A plus B into A minus B. So OD plus OB into OD minus OB. A plus B into A minus B. And easily we can put the value of each and everything. So OD is 10.3 by 2. You see, 10.3 by 2. And OB already we have found. OB 8.3 by 2. So we can just apply the value. And if you simplify, we get 18.6 by 2, and this 2 by 2, we can cancel this. It becomes 1. So this is nothing but 18.6 by 2 is 9.3. So BD square is 9.3. Therefore, BD is equal to square root of 9.3 units. That's all. Clear? And now coming to the next topic, rationalize the denominator, or simply we can say rationalization. Okay. First, we see briefly about this topic, and we will move to the next sum. Clear? So rationalize the denominator. For example, we take 1 by square root of 2, and here the denominator is root 2. So root 2, is it rational or irrational? Irrational. Okay. So in the denominator, it is irrational. So rationalize the denominator means you have to convert the irrational form in the denominator to rational form. You see how I am doing this? 1 by root 2 and multiplying the given 1 by root 2 by root 2 on both numerator and denominator. So I am multiplying root 2 both on numerator and denominator with the given number 1 by root 2. And what happens next? Numerator is 1 into root 2, and you see the denominator root 2 into root 2. That is what? Root of 2 into 2, nothing but 2. So square root of the same number, root 2 into root 2 is 2. So now it is 2 is rational. So here 1 by root 2, which is equivalent to root 2 by 2, and now the denominator here becomes rational. Irrational to rational. So this is called rationalize the denominator, or simply rationalization. And now we have to note some points. Root 2 in this problem, root 2 is the rationalizing factor. We say in short RF, capital R, capital F, rationalizing factor of 1 by root 2. For this 1 by root 2, how we can make it the denominator rational in this 1 by root 2 by multiplying root 2 on both numerator and denominator. So we can say root 2 is the rationalizing factor of 1 by root 2. So like that, for different problems, so we have to multiply on both numerator and denominator by the corresponding rationalizing factor. Clear? And we will see the exercise 1.5 fifth sum. Let us continue. Fifth sum. Option 1, 1 by root 7. So here they are asking, rationalize the denominator of the following. Rationalize the denominator. So how we can say easily? By observing the previous problem, we can say 1 by root 7 into, what should be multiplied? What is the rationalizing factor here? The root 7 only. By observing the denominator, we have to tell what is the rationalizing factor. And what you get? The same thing only, you are multiplying both on numerator and denominator, so there is no change in the problem. So, you get root 7 by 7. Root 7 into root 7? 7. So now it becomes rational in the denominator. And this is the solution for the given question. So we have rationalized the denominator. Rationalizing the denominator here. You know what is meant by rationalizing the denominator? The denominator is irrational here and we have changed rational. Root 7 becomes 7 in the denominator. So that is called rationalization. And now coming to the next question, option 2. And already I have told you the rationalizing factor. How to find the rationalizing factor of a given problem? According to the given question and given denominator of the question. So here, what to say? What is the rationalizing factor here? Root 7 minus root 6 is in the denominator. So, root 7 plus root 6 is the rationalizing factor of the denominator. So, we have to multiply by root 7 plus root 6. So, R here is root 7 plus root 6. Here minus, so you have to put plus to get R. And you have to multiply 1 by root 7 minus root 6 is equal to 1 by root 7 minus root 6 into root 7 plus root 6 by root 7 plus root 6. You see how I am doing that? And now, continuing, the numerator you multiply 1 into root 7 plus root 6. So you get the same root 7 plus root 6. And what comes in the denominator? Just you multiply. You can put the bracket. To avoid confusion, you can put bracket. So this is of the form A minus B into A plus B. This is the multiplication for both numerator and denominator. Okay? And A minus B into A plus B. It is of the form. So we can apply that identity. What is A minus B into A plus B? A square minus B square. So root 7 whole square minus root 6 whole square. Do you remember that identity? Okay, I will write down both here. A minus B into A plus B is equal to A square minus B square. So this is the identity I am applying here. Okay. For A root 7, for B root 6. A minus B, A plus B get A square minus B square. And again, this is same root 7 plus root 6 by this becomes 7 and this becomes 6. Root 7 the whole square is 7. Root 6 the whole square is 6. And now easily the denominator becomes 7 minus 6, 1. So it is negligible. You don't need to put 1 in the denominator. So as it is, the answer is root 7 plus root 6. So that is divided by 1. So by 1 only 2. So The given problem 1 by root 7 minus root 6 is equivalent to this one, root 7 plus root 6. That is equal to root 7 plus root 6, which is the denominator is rationalized. Okay, here the denominator is root 7 minus root 6 by here, but here is one denominator. So the answer is root 7 plus root 6. This is the rationalizing form. Clear? And we will say 2 more sums are there. And you take as formula. I will write down here option 3, option 4. 1 by root 5 plus root 2 and then 1 by root 7 minus 2. You have to be carried here. There is no root symbol here. Only for 7 root, but for 2 there is no root symbol. So you have to take, that is the rationalizing factor as here root 5 minus root 2 and here root 7 plus 2. Root 7 plus 2. That's all. So by taking that you proceed and you can easily get the answer. Clear? And let us see the extra sum of this exercise. Find the value of a and b such that 5 plus root 3 by 7 plus 2 root 3 is equal to a minus b root 3. So in this statement or in this equation, you see the right side, the unknown a and b are there. So the question is, we have to find the value of these two unknowns. So here, I am taking that left hand side. So I am trying to rationalize it as we did in the earlier problems. So you have to rationalize the denominator of this and you can get the a and b by comparing the coefficients. This is the method. So 5 plus root 3 by 7 plus 2 root 3. You can write as 5 plus root 3 by 7 plus 2 root 3 into, we have to multiply by the rationalizing factor of the denominator. Can you say that? What is that? 7 minus 2 root 3 and again we have to divide the same 7 minus 2 root 3. So this is the way to rationalize the denominator. So by using that method, rationalizing the denominator, we are going to find the value of the given unknowns. So you see, easily we can do this. You see the denominator is, first of all, denominator usually is 7 plus 2 root 3 into 7 minus 2 root 3. It is of the form a plus b into a minus b. So that already I wrote on board. So what is that? A square minus b square. And now coming to the numerator, it is just multiplying the two brackets. Okay. So first 5 into 7. What that? 5 into 7? 35. And then plus 5 into minus 2 root 3. So minus 5 into 2, 10. And then 10 root 3. Is it clear? And then plus root 3 into 7. You can write as 7 and then root value root 3. So 7 into root 3. And now this plus into minus becomes minus. And root 3 into 2 root 3. Root 3 into 2 root 3. So these are the numerator. Thus I multiplied the two brackets in the numerator. Now what about the denominator? I already told you. A plus b into a minus b is nothing but a square minus b square. And here a is 7 and b is 2 root 3. So you put square. And now what about that numerator? We have to simplify again. 35 as it is. And this is minus 10 root 3 and this is plus 7 root 3. So both are root 3 terms. So minus 10 plus 7. So what is the value of minus 10 plus 7, which is bigger? Minus 7. So minus, the difference of 10 and 7 is 3. So 3 root 3. Clear? And here minus, minus root 3 into root 3 first of all becomes 3 and then this 2 is there. So 2 into, you can separately 3 into 2. Root 3 into 2 root 3. How to multiply that? First root 3 into root 3, 3. And then 2 is there, so put into 2. And the denominator what happens? 49. 7 square is 49. Minus. Here we have to be very careful. First of all, you have to apply the square for 2. What happens? 4. So within bracket you write 4 and then into root 3. If you apply square for root 3, what happens? 3. That's all. And now come to this side. This is equal to, what about the numerator? 25. And then minus 3 into 3. And then minus 3 into 6. Minus 6. Divided by 49. Minus, what is 4 into 3? 12. Is it clear? And next step, 35 minus 6. What is that? 35 minus 6? 29. So 29 and then minus 3 by, what is 49 minus 12? 37. And this we can write as 29 by 27 and then minus, that is getting the numerator, we can write that 3 by 37 root 3. So clear? Now, what is given in that question? This left hand side is equal to a minus b root 3. So comparing with a minus b root 3, we get a equal to, instead of a, what is that? 29 by 37. And instead of b, what is that? So for a, it is 29 by 37. And then minus sign, here also minus sign. And here 3 by 37 into root 3 and here b root 3. So root 3 same. What about b? 3 by 37. So this is the answer of a and b. Is it clear? So like that, many more problems I will give on the worksheet. So you finish it.